citizens, back with me again, Aji Gautama Putra. I am your lecturer for parallel and distributed systems. This is our ninth meeting, parallel programming model. In the third video, we are going to discuss about shared memory. So, like we discussed before, shared memory uses centralized memory used by different kind of CPUs. And in a shared memory paradigm, if a CPU has a program, it is usually called thread, which you have learned previously in operating system. So here we are going to make an example CPU 1 here. Let's name this CPU 1, and this is 2, and this is 3, and this is 4. So CPU 1 has thread 1, we'll just call it T1, and T1 uses a resource and memory data called A. And just to continue, CPU 2 has something called T2, thread 2, CPU 3 is running T3, and CPU 4 is running T4. So each of these threads are using memory data, which is T1 uses A, T2 uses B, T3 uses C, and T4 uses D. In this example, there are no problems because T1 is using A, and T2 is using B, T3 is using C, and C4 is using D. So nothing happens here. There are no problems. But the problem arises when something happens like this. So in our second example, for example, we have CPU 1 and CPU 2, which CPU 1 runs T1 and CPU 2 runs T2. And for example, we have a data called A, and T1 needs A, and T2 also needs A, and both of them can use A because A is in a shared memory, as we stated before. So because they share a memory, they can share A data. And the problem arises is something called a race condition. As you have learned in operating systems, a race condition happens when if two processes use the same data. For example, T1 needs A to be 10, but it is changed by T2 and it becomes 15. And that is a problem because T1 needs it to be 10. So there is an unsynchronized data. So the solution to this is synchronization. So like we have learned in operating systems, when there is a race condition, there is a solution called mutual exclusion, which is the focus of something called synchronization. And this we will learn in a shared memory paradigm. And in synchronization, there will be several terms like lock and release and wait and notify. And in the programming world, shared memory programming, there is one famous programming type which is called OpenMP. And MP here stands for multiprocessing. So OpenMP is open multiprocessing, and which in that programming language there are things that we have discussed earlier, which is mutual exclusion and notify and wait and lock and release. So that is the end of our third video. In the first video, we have discussed about shared memory. In the next video, we will discuss about distributed memory. Thank you for your attention. I'll meet you in the next video.